Okay, and now here's where it all comes together. Factoring plus the symbols game equals fraction mastery. If you can factor things and you understand the symbols game, you are a master of fractions. For example, suppose that we want to reduce, 16/40ths. Step 1, factor. 16 is 4 times 4, which is 2 times 2 times 2 times 2, and down below 40 is 4 times 10. 4 is 2 times 2, and 10 is 2 times 5. Okay, that's the factoring. Where's the symbols game? You got the same thing above and below, you can get rid of them. Same thing above and below, you can get rid of them. Same thing above and below, get rid of them. There's nothing left. This is the take away as much as you can game. You are left with 2/5. That is 16/40ths reduced. What else can we do? We can find equivalent fractions. Find 3 fractions equivalent to, what's your favorite fraction? 4/7. Okay, 4/7. What is that? You put a 4 up top, you put a 7 down below, you put anything else you want in. This is one of those really trick math problems where you have freedom. You can put a 5 up top. 5 up top, 5 down below. That is 20/35 is the same fraction as 4/7. Maybe we want to, maybe you don't want to put a 5 top and bottom. Maybe you want to put a 2 top and bottom. Then we're talking about 8/14. Maybe you want to put a 2 and a 3 up top. Well, then you have 6 times 4, you have 24 up top, and down below 6 times 7, 42. This is how you can find equivalent fractions. What else can you do? Let's say you want to compare fractions. You want to compare what is bigger, 4/9 or let's say 5/12. Which is a bigger fraction? Well, they seem a little close. How do we do this? Well, factor. What have we got over here? On the left we have 2 times 2 over 3 times 3. And over here we have 5 over 2 times 2 times 3. Well, it's very hard to compare this. It says, would you rather have 4 slices of cake where it takes 9 of those slices to make a whole cake? Or would you like 5 slices of cake where it takes 12 of those pieces to make? So, do you want fewer pieces that are bigger or more pieces that are smaller? Well, the answer is, it depends. If they were the same size pieces of cake, it would be so much easier. What's better? 12 pieces of cake or 11 pieces of cake? 12 pieces of cake. If they're all the same size, 12 pieces is better. So what we want to do is we want to make the denominators the same. How do we do this? Well, on the left we've got 2 3s. The one on the right doesn't have a 3. Symbols game. Put a 3 in the top and the bottom. Now the fraction on the right has 2 3s just like the one on the left. Hey, the one on the left doesn't have any 2s. Give it 2 2s, top and bottom. And now we have the same denominator. Now we have found equivalent fractions to these that happen to have the same denominator. 4 times 4 is 16. We have 16 over 9 times 4, 16/36s versus 15/36s. Aha! Would you rather have 16 slices of cake or 15 slices of cake where they're all the same size? It takes 36 of those slices to make a whole cake. Hey, 16/36s is better. And therefore, because 16/36s is the same as 4/9, and 15/36s is equivalent to 5/12, that means that 4/9 is bigger. There is a shortcut for this. Anytime you're comparing fractions, one clever trick is you can take your 4/9 and your 5/12, you can skip the factoring. You could just say multiply this one by 12 top and bottom, the denominator over here, and multiply this one top and bottom by 9, and you're going to have the same denominator, 9 times 12. And the impressive thing is, who cares what 9 times 12 is? It's the same. 4 times 12 is 48. 5 times 9 is 45. So whatever that denominator is, it's the same, and therefore 48 of those is better than 45 of those, so this fraction is bigger. The super duper shortcut is to just multiply across. You say 9 times 5 is 45, and you say 12 times 4 is 48, and you say, hey, 48 is bigger, therefore this fraction is greater than this fraction. Woohoo! What else can we do with this wonderful symbols game? Hey, we can add and subtract fractions. And this is why earlier, I mean, we did some crazy factoring, but you don't really need to know how to factor 246 on a regular basis. The kinds of fractions that people deal with are much more reasonable. Suppose we want to add 5/12 plus 4/9, something like that. What do? You factor them out, and so this is 5, that's our prime number, over 2 times 2 times 3, and then we want to add 4. You don't really even need to factor the numerators. 4 over 3 times 3. And we say it's very hard to add these fractions because they're different. They have different denominators. You have 5 somethings and you're adding 4 somethings, but those somethings are of different sizes. This kind of confuses some people, but when you have twelfths, it means it takes 12 to make a whole. Ninths means it takes 9 to make a whole. So in fact, the larger your denominator is, the smaller your fraction is. So this is, anyway, we talked about this. So what do we want to do? You basically were playing the fairness game. Little Kim over here has 2 2s and a 3, and Mike has 2 3s. Kim wants a 3, so you give her a 3. But again, slightly more advanced. We're playing the symbols game. You can't just stick a 3 in the bottom. You have to stick a 3 in the top and the bottom. Now Kim's totally happy. She's got everything she wants, everything that Mike has. Mike wants those 2 2s. Where do you put the 2 2s? You put the 2 2s in the top and the bottom. And when you multiply these out, you get 15, 4 times 9, 15 36s, plus 4 times 4, 16 36s. And these fractions denote the same thing. It's like saying if you had 15 cakes shared among 36 people, and then you have 16 cakes shared among 36 people. That's the same thing as 31 cakes shared among 36 people. That's another way to look at this. Adding fractions with common denominators is to look at the number line. Only make a real big number line. You have the start, which is the same thing as 0, and then you have 1, and 2, and 3. Let's say we divide these into half steps. So this is one whole step. Well, let's make it a half step. So this is 1 half step, and this is 1 half step, 2 half steps, and then 3 half steps, and 4 half steps, and 5 half steps, and 6 half steps. And this confuses some people to think that numbers have many, many different names. You can say 2, you can say 4 halves. So what? And what happens if you want to do 3 halves plus 2 halves? Well, you start. You take 1, 2, 3 half steps, and then you take 2 more half steps, 3 halves plus 2 halves, and you end up at 5 halves. And basically what we're saying is if you're adding steps of the same size or slices of cake of the same size, the size doesn't change, the number of pieces have. So 3 half steps plus 2 half steps is 5 half steps. Units and variables. This is a big result. Units and variables are just factors. They're really just factors. So 5x is really 5 times x. Which means that if you have 10x squared y over 15x to the 4th, we factor it, 10 factors into 2 times 5, x squared is x times x, y is just y, Down below 15 is 3 times 5, and x to the fourth is 4x's. And you just reduce. You say, there's a 5 top and the bottom, get rid of it. There's an x top and bottom. I don't know what this x is, but x divided by x's goes away. X can't be 0. I always have to say that. X over x goes away. Now we can't clear anything else out. So what do we have? We have 2y up top, and down below we have 3, and then 2 x's, 3x squared. One useful thing to point out is that what happens if you want to do something like reduce, let's say, 4/20ths. Well, what's so bad about that? Up top 4 is 2 times 2, and 20 is 5 times 4, which is 5 times 2 times 2. We get rid of a 2, bang, bang. We get rid of a 2, bang, bang. What do we have left up top? We have nothing left up top. But what kind of nothing is it? Are we adding and subtracting, or are we multiplying and dividing? Fractions are the same thing as dividing. We are multiplying and dividing. Therefore, the nothing that is up top is a 1. 4/20ths is the same as 1/5, not 0/5. A lot of people make that mistake. Same thing could happen like 12 over 2. 12 over 2, that's 2 times 3 over 2. We cancel it out. What do we have left? We have 2 times 3 over 1. 6 over 1. That's the same thing as 6 divided by 1. That's 6. What have I done? I've just said that 12 divided by 2 is 6. Yes, you probably already knew that. But you can do it with fractions. You can do it in lots of different ways. And the beauty of mathematics is, as long as you don't make a mistake, no matter how you do a problem, you will get to the right answer. One more subtraction example. Let's say, let's do something crazy. Crazy example. I have to illustrate that. Crazy example. Let's say we have 3x over 10y squared, and we want to subtract from that 5 over 6xy. Looks like a really, really hard problem, but it doesn't have to be. What have we got? Factor everything. 3 times x, there's a 3 and an x up top here. Down below 10 is 2 times 5, and y squared is y times y. And then we want to subtract. What do we have over here? 5 is prime. Yay! 6 is 2 times 3, and x is just x, and y is just y. Well, play the fairness game. This denominator says, he got a 5, I want a 5. Fine, fine. Wait, no. I have a 5. He has a 3, I want a 3. Fine. You get a 3, top and bottom. That's the whole thing. Over here, let's see. Now, what else do you want? You want an x. He's got an x. You get an x. Great. Is there anything you're jealous of? He's got a 2, you've got 1. He's got a 3, x and y. You're all set. This fraction over here, but I want some stuff. What do you want? It's got a 5. You got the 5 on top, but you want the 5 down below. Fine, have a 5 down below. You got the 2, you got the 5. Well, they've got 2 y's. You only have 1. Fine, have another y. And that's it. We have the same denominator. 2 times 3 times 5, 1x and 2 y's. Put this all together, and we get 3 times 3 is 9x squared over, 1030 xy squared, and we want to subtract 5 times 5 times y is 25y over 6 times 5, again, 30xy squared. We have a common denominator. And when you combine things with common denominators, that denominator stays the same. 30xy squared. So many people want it to be more complicated. It doesn't have to be more complicated. If you add quarters to quarters, you get quarters. If you add fifths to fifths, you get fifths. If you add 30xy squareds to with 30xy squareds, we get this. But what do we do at the top? We have to subtract. We have 9x squared minus 25y. Those things can't be simplified. And so that's it. It's a crazy example. People will try. They'll try to get those 16 something or others. You just can't. You just can't.